I'm Kirsty, and my group members are Kathy, Sam, and Grace, and we'll be exploring the cost curve in different scenarios in the short run and the long run. So we are assuming that the company is trying to maximize profit and minimize costs. We also assume that the capital is fixed in the short run, and because the company will gain more resources as they grow, they will also gain more capital, so capital is variable in the long run. I will just give a definition of the marginal cost and marginal revenue before we move on. The marginal cost is how much extra it will cost to produce one more unit. We all know that the derivative is the rate of change, so the marginal cost is the rate of change of the total cost. The marginal revenue is the additional revenue generated by increasing product sales by 1 unit. I will now explain it in the long run. So the long run average cost curve is determined by the short run average cost curve. This section of the long run average cost curve is increasing return to scale, and this section is diminishing return to sale. Kathy will now explain the marginal cost and marginal revenue in a very specific situation.
I'll explain marginal cost and marginal revenue in the short run. For this specific example, I will explain how many toys should be sold per day to maximize its profit. The total cost and price formula were given, and we can use the derivative of total cost to calculate the marginal cost formula. And because total revenue is price times quantity, we can also calculate this. And marginal revenue, as mentioned before, is the extra revenue produced extra 1 unit. So we can calculate the derivative to calculate the marginal revenue formula. And average cost is basically the total revenue divided by the quantity. So we can now move to the graph as this one. Basically, for profit maximizing rule is marginal cost equals to marginal revenue. The reason is that we can explain this in 2 scenarios. One is when marginal cost larger than marginal revenue. Basically, if total cost basically is this part, the right hand side part, if marginal cost larger than the marginal revenue, if we increase the quantity by 1 more unit, the total cost will increase by the value of marginal cost. The total revenue will increase by the total value of marginal cost, but because the marginal cost is greater than marginal revenue, so the cost will go up by more, so the profit will decrease by the marginal cost minus marginal revenue, so which means we will have the marginal loss. So we should decrease the quantity of the product to increase the profit. Another scenario is marginal revenue is larger than marginal cost, which is the left hand side part. If marginal revenue is larger than marginal cost, total revenue will increase by the value of marginal revenue, the total cost will increase by the value of marginal cost, but marginal revenue is larger than the marginal cost, so the total profit will increase by marginal revenue minus marginal cost, which is known as marginal profit. So we will continue to increase quantity to increase our profit. So only when marginal cost equal marginal revenue, we will get our maximized profit, which is this formula equals to that one. So we can get a new quadratic formula and use the quadratic calculation to calculate the maximized product quantity, which is Q equals 16. So when Q equals 16, we can get the maximized profit is total revenue minus total cost. We can put Q equals 16 back to the 2 formulas, and then we can get the maximized profit is equal to $2,432. Now Sam will explain the long run scenarios.
Okay, see. Now I'm going to explain how to derive the long run average cost by using Cobb-Douglas production function. So Cobb-Douglas production function look like this, and then where A is total factor of productivity, L is a labor input, and then K is a capital input, and then alpha and beta is a output elasticity of labor and capital, and this is determined by inefficiency in management and the division of labor and available technology. So assumption to this model is production is determined by only labor and capital. If either labor or capital vanishes, then so will production. Labor and then capital both are variable, and the cost per unit of capital and the labor are constant. And P, L, K, everything is more than 0, and the alpha and beta is greater than 0 and then less than 1. Depending on the sum of alpha and beta, and then total cost curve shows the different trends. So when alpha plus beta is more than 0 or more than 1, it is called increasing return to scale. In this case, when labor and capital increase, production increase more than the input. Therefore, average cost decrease in this way. And this one, alpha plus beta. When alpha plus beta is 1, then it is called constant return to scale. In this case, like labor and the capital increase twice, but however, also the quantity of production also increased by twice. That means like average cost stays the same. So it is expressed as a constant slope of 0 here, and this one is opposite as this one.
I'll make a final conclusion. Firstly, I'll introduce the law of diminishing marginal returns. As the output increases, marginal cost increases at increasing rate, which is not a good effect we wanted, as we want the profit maximizing. But I just want to explain that why does this law happen? Because of the labors, because of adding more labors, the labors becomes lazy. It is not the reason, because we think that there's a relationship between the fixed factors and the variable factors. For example, if we produce pizza, we only have one oven, there's no use adding more labors because some labors might not join into the production producing the pizzas. But it is not bad that that doesn't affect we achieve the profit maximizing goal, because we could get the MC equals MR, we get the profit maximizing. Then we jumped into the long term. We could change all of the fixed factors into the variable factors. We could increase the size of company. We select one plant with 1 machines, 2 machines, 3 machines, or 4 machines. Then we get the lowest average total cost. At this point, we get the minimum efficient skill. Then we get the so it is a profit formula. We get the minimum average total cost, and so the average total cost decreased, and number of products increased. For the price, I want to talk about the monopoly company. They always have the products having their own special characters. For example, the macro software produce a kind of software. Other companies cannot have this kind of technology. Therefore, they can set a high market within a reasonable range to get their maximum profits. That's all contents for our topic. Thank you for listening.